What does a longitudinal wave train look like? And this is a formal example, so usually formal examples are of a slightly more mathematical nature, and they're just part of a story that I'd like to show everybody so that you know either where something comes from, or in this case, maybe how things should look for a longitudinal wave. So let's go ahead and look at that. In this case, instead of formulas and steps telling the story, we just have a picture, and the picture has a graph that looks like a regular graph of a wave here, so you can see this wavy looking graph there. And the interpretation of that graph is that that represents the displacement of the medium. Now there are also these vertical lines, and I used Mathematica, which is a software program that has a number of advanced mathematical functions to generate these vertical lines based on the displacement of the medium that is also graphed here. And if the displacement of the medium were zero, in other words, if there were no wave passing, all these vertical lines would be evenly spaced. It might be a little strange, though, to see that the point where the vertical lines are the most compressed does not correspond to a crest in the graph of the displacement of the medium. And it turns out the reason why that is because this represents displacement of the medium to the right. And then if you go to the right of this compressed region, this negative point on the graph here represents displacement of the medium to the left, which means really the medium between those two spots is being pressed together. And contrast that to this rarefied spot right here, where the leftward displacement of the medium just to the right of that spot, and then the rightward displacement of the medium just to the left of that spot suggests they're being pulled apart. And so that explains why here the medium is very rarefied and therefore has the lowest density right at that point. So this picture, though, gives you a visual, though, of how a longitudinal wave might look as it passes through its medium. So this could be a sound wave. As a sound wave passes through the air is going to compress and rarefy in response to the passage of that wave. We can also demonstrate this on a slinky. You can send a longitudinal pulse through a slinky just as well as you can send a transverse pulse through a slinky. And when you look at the longitudinal pulse, it travels pretty quickly, but if you look real close, you'll be able to see these kind of compression regions sort of traveling through the slinky, and it looks, if you could take a snapshot of that, it would look a little bit like what's in this picture.